In this video, I'm going to be talking about one sample analysis. Now, this doesn't mean I have an individual sample which I'm trying to analyze. I can still have a range of data. However, I will not have taken repeat measures. Once again, I'm going to be using the JASP software, and I'm going to use data that's been taken from Mark Goss-Sampson's book, which you can get as a free PDF from the support section of the JASP website. I've already loaded the data into JASP, and you can see that in this situation we have 23 people and we have measured their height and mass. And it's useful to get a sense about whether these are average people, whether they have a typical weight, whether they are heavier or lighter than normal, or if they are taller or shorter. And if we don't have any other groups to compare to, the only thing that we can do is look to a known value. In 2017, the average person was 178 centimeters tall and 83.6 kilograms in mass. I'm going to walk through the previous steps that have been outlined in prior videos. So we'll just start by the descriptive statistics, and we can do these at the same time. So I shall put the variables in, and we can see that we have minimum of 64 and 167 and a maximum of 88 and 187. And so there's nothing in here you would immediately look at and think that is an exceptional value. I'm not seeing anything that was 40 kilograms or anything that's 150 kilograms that I think that's a very unusual value. I can look at the Shapiro-Wilk p-value, and I can see that both of these are above 0.05, suggesting that we have a normal distribution, which allows us to do parametric analysis. For the sake of keeping the results window as small as possible, I'm just going to remove these values so that when we move to the next section, we can focus on the new information as it appears. A one sample analysis is listed under t-tests, and I should point out that even if the Shapiro-Wilk indicated that the data was not normally distributed, I would still head to the one sample t-test because the non-parametric equivalent is within this section. I'd also like to draw your attention to the fact that even though I've now moved on to the next test, the descriptive statistics section stays within this menu area, and I can expand this to review at any point in time. This is a very nice feature because it means that when it comes to writing up method section later on, you can see the statistical analysis that you completed in the order which you completed it. With a one sample t-test, even though in the descriptive section, then I put both variables into the variable box at the same time, I need to compare these parameters one at a time when I start to look at the t-test because I need to add a test value. Now this is the value which we are going to compare our range against. So all of our individual participants are going to be compared against the national average, and the average height for a male in 2017 is 178 centimeters. So I'm going to pop that in the test statistic. And you can see that I can look to see, are the test values not the same, greater or smaller? I can include a normality check at this point if I've not done that so far, so I can reconfirm that the p-value is above 0.05. I could include descriptives, or I could include descriptive plots if I wanted additional information, which all could be copied over into Microsoft Excel or any word processing software when we're writing up. I'm going to focus now on, we can see that much like the normality test, the threshold we're looking at is 0.05. In this case, if the p-value is less than 0.05, we would say that these values that we have acquired are statistically significantly different from the national average. And you can see in this case, in the height, they are not. As I mentioned earlier, if the normality test had suggested the data is not normally distributed, then I would complete a Wilcoxon test. I'll just swap these over here, and you can see that very, very quickly the results panel updates. And if I choose to do a non-parametric analysis, which is an option for normally distributed data, the p-value is still indicating there is not a significant difference. Once I've completed this, I can swap my variables over. I'll stick to a t-test because do the normality again. We can see still greater than 0.05, so we're safe to carry on with either test if we choose to do so. I do need to update because I've still got the height in there, and the average male mass in 2017 was 83.6, and we can see here that this actually is significantly different. Now at this point we don't actually know, is that greater than or less than, so I'm just going to bring back my descriptives, and we can see that our average mass in the data sample we have here is 72.9, and that the average in 2017 was 83.6. And it's an important point because often people get carried away in their initial assessment and they say, these values are statistically different, and we need to state the direction of the difference. So we can say this group is statistically significantly lighter than the national average in the year of 2017. Once again, if the data was not normally distributed, it is in this case, but if it was not, I would simply change these over to Wilcoxon, which I would interpret in exactly the same way.